All right. Good afternoon, everyone. Um, so I want to point out that the tutoring center is now open for business, and so if any questions about the homework, you would like to get a second opinion from a tutor or from one of your classmates, show up there. Um, Talk about your issues, have someone help you work through this. If there's a concept that you'd like someone else to explain to you, that's what they're there for. The department pays for it; it's free to you, and so I highly recommend it. Yeah. I have no idea, but it says here in tiny font.
It's right around the corner.
No, it doesn't say.
Like directly out the door on the other side of the wall.
All right, so it's on this floor somewhere.
Okay.
You'll figure it out.
There's a giant sign and everything.
Okay. Okay.
I even have braille. Yeah.
So so just check it out and see if it's any good. And in the next few days, I'm going to go through the class list and see who I'd really want to see at tutoring, and then I'll let you know just to give you the extra push. But it is a good resource. And also, I mean, those are the people who can tell you it'll get better. I know it's confusing, but that's just the way it is. And when I tell you, you won't believe me anyway. But yes, it will get better. All right. So I wanted to talk a little bit about one of the homework solutions, and then go on to how to draw images. And so the one that I'm interested in is this thing here about the cash register. So I know it's in kind of very tiny font, but maybe you can open up your desire to learn and read along with me. So the question was to make a change to this already changed cash register. So if you recall, there's a cash register in the book, in one of the worked examples or how-tos, and that cash register takes care of purchase and payment. And then in the homework, we added two fields to keep track of the total of all of the sales in a particular period and the total number of sales. And then I handed out a solution, and that solution, for whatever reason, had the record purchase update the sales total, and it said sales total. That sales total equals sales total plus what? Plus purchase. Okay, that's the story. He's sticking with it. So let's see whether that can work. So so when you have a situation like this where you have a particular logic that you have in mind, how do you know whether it's right?
But is that the one that was in there? Not the one we changed.
Yeah.
But I think it was amount.
So now he's changing his story. Now he says it should be amount. So which of the two should it be? And there are two ways of settling this kind of question. One is you can look at this and apply the force of logic. Yeah?
It should be amount because purchase is being added every time you run through the purchase. So
Okay. So what you just heard was the force of logic in action. He gave a very good reason as to why purchase is in fact wrong, namely that purchase incrementally gets larger and larger, and then if you add it each time, you're going to add things more than once. And so that's excellent when you have the insight to do this. But you're often in a situation where you don't have that kind of insight, where you have a lesser understanding of what the class does. And at that point, there is a very good tool to deal with that, and that's what's called the code walkthrough. And so I want to show you how you can walk through some scenarios with pencil and paper, write up what happens, and gain that superior insight in that way. So insight is always great, but we don't always have it. And so the question is, what do you do if you don't? And so the reason that I pitched the walkthrough technique is that I used to try to explain to the students the thing with the insight. And I would say it again and again and again, maybe in 3 or 4 different ways. And it just turns out that until your brain is ready for receiving the message, it doesn't actually matter what the message is. And so we'll do it the other way. Let me get a blank sheet of paper here. Here's my blank sheet of paper. So to make a walkthrough, what you do is, this is going to drive me totally crazy. Just going to do my cheap way. I know why. So you make a table and you put for each of the instance variables, and also if you want to track them for each of the local variables, you put the value. So for the cash register, what did I have? You're going to have to help me along because I can't see it. What are the instance variables of the cash register? Purchase. Payment. All right, next we need to come up with some scenario that would exercise these. So we're going to come up with some set of method calls that hopefully give us some insight into what's going on. So what's the method that you call to buy something? Is it add item or enter? I don't remember. What's that? Record purchase? All right, so let me call my cash register CR. And because I don't have a lot of space here, let me just call this method RP for record purchase. And you'll know what I mean. So let's record a purchase for $1. Let's record another purchase for $2. And then one for $10 just for fun. All right. Now, you're going to have to read me the instructions that we have in the record purchase method right now. What's the first line say? No, that's the actual code. I want to walk through the actual code that's in there. Not what it should do, but what's actually doing. That's not always the same thing.
Record purchase double amount. Double amount equals purchase plus amount.
Okay, so this is the amount here, right? So let me mark this too. Say again?
Double total equals purchase plus amount.
No, so I do need to keep track of total. I'm going to cram that in here. Okay, so total equals purchase plus amount. How the heck do I know what's in purchase right now? At some point this object was constructed. Does the constructor set purchase to 0?
Yep.
Yeah, beautiful. All right, so I know there's 0 in there. So now you say total equals purchase plus amount. So now total is 1. Next line.
Purchase equals total.
Purchase equals total. Okay.
And that's it.
Okay, and now in the line that we have, let's do it the wrong way to show why it was wrong. In the wrong line, it said sales total equals sales total plus purchase. Sales total equals, because before there was a 0 in there, I should put it in there. And then we have 1. All right, let's do it again. The first line said total equals purchase plus amount. So that's 1 plus 2, so total is now 3. Then it says purchase equals total. And then it says sales total equals sales total plus purchase. could now be 4. So now we do the same thing with the 10. Total equals purchase plus amount. Purchase equals total. Sales total equals sales total plus purchase. That is 4 plus 10. No, I'm all wrong here. This is 13, right? Yeah. So we have 13 plus 4, 7. Okay, and now what do we do? How do we pay? Now, enter payment.
Payment equals amount.
Now, what's the name of the method? Is it enter payment?
Yeah, enter payment, double amount.
Okay. And let's say we pay $30. No, 20. And okay, read me the first line.
Payment equals amount.
Okay.
That's it.
Okay. Give change.
Public double give change. Double change equals payment minus purchase.
Now I need a local variable for change. I'll cram it in here. It's payment minus purchase. Purchase is 13, 7. Okay.
Sales count equals sales count plus 1.
Okay.
Sales total equals sales total plus purchase.
No, that was the one that you put in for your solution.
Oh.
Or that I put in for my.
Oh, I put, this is your solution.
Yes. Okay. So we weren't having that. Yeah. All right. Any others?
Then he sets the purchase and payment to 0.
Okay. 0.
And return change.
Return change, which is $7. Okay. All right. So so that's how you do this kind of walkthrough. And now at this point, when we look at it, we see that the sales total is $17, and that can't be right because we only bought $13 worth of stuff. So that shows that something must have gone wrong. And at that point, then one can start thinking about it. But being able to simulate an object like that is actually very important, particularly if something goes wrong. It's this is going to happen to you all the time, that you think one thing happens, actually another thing happens. And the best way of coming to finding out where the bugs are is to do this manual walkthrough on a piece of paper. It sounds a little laborious, but it's an excellent tool to understand what's going on. Now, so in this case, we would then see there was something wrong, and then we can try to understand what the numbers mean. We're going to be practicing this in the lab, and it's also something that I just highly recommend. Just anytime that you get stuck with something, to whip out a piece of paper and just walk through a few lines of code, see how these variables get updated. There's research on which kind of student succeeds in beginning programming. And so where that try, is it important to be ambitious or hardworking or whatever. And so it turns out that the one thing that correlates highly with being able to get through the course is to be able to think just like the computer. If you can think just like the computer, you're golden. And the computer is really dumb. As you've just seen, it's really boring and dumb to do this thing, one boring step at a time. But if you can see what the computer does in this mind-numbing and slow sequence, then it's possible to adjust your programs to do it right. And what many people do wrong in programming is that they ascribe mythical and magical powers to the computer. They think that the computer can do all of these things. And that's, of course, not true. The computers are supremely dumb. They do very, very simple steps. And your job as a programmer is to invent these simple steps and, of course, to do it in the right way. So this is something that you definitely want to practice. And I realize it's an unpopular thing because when your program is not working, the last thing people want to do is get out a sheet of paper and start writing down these numbers. But it actually is a very successful way of doing it. Much more successful usually than trying to scratch your head and coming up with and trying to get some insight right then and there, because that insight is sadly often not coming. All right, moving on. If the Smartboard software lets me to how to draw a frame and stuff. So we're going to do a bit of graphics, and the reason is not so much to produce wonderful pictures. You could do much better pictures with Photoshop or whatever, but it's always nice to be able to have a visual idea of what goes on in a program, and so I'll be creating assignments that give you some visual feedback, and it's more enjoyable, and it makes it easier to learn stuff. Unfortunately, in Java, there's a certain amount of pain that you have to go through to put up the simplest drawing. And I'm just going to tell you what that pain involves, and then we're just going to copy and paste that every time we need it. So for no good reason, one has to, first of all, come up with a frame. A frame is like a window that one can paint something inside. You have to construct the frame. You have to set its size, because the default size for a frame is what?
0.
Is 0 by 0, because that maximizes the annoyance to the programmer. No one ever wanted a 0 by 0 frame, right? So I don't know why they chose that default. Then you can set a title if you like, but it doesn't really matter. Then you have to set the default close operation. By default, when you close a frame, it goes away, but your program does not exit. That too is not something that most people want, so one has to specify it. And then finally, you have to make the frame visible, because the default for a frame is to be hidden, because also that is the more inconvenient setting. So the designers of this particular library hate people, and so they made it so that every one of the things is inconvenient. That's just the way it is. What I always do is I copy and paste the entire thing and don't even read what's inside. So and then when we go through all of this, then you get an empty frame. We do not want an empty frame. We want to have a frame where stuff appears inside. So to do that, you have to draw on the frame, on the surface of the frame, but you can't do that. That would be too convenient. Instead, you have to draw on an object of another class called JComponent. Why can't you draw on a frame? Again, there's no particular reason why it's not so. It's just not how they did it. In order to do drawing, you have to put drawing code into a method that's called paintComponent. And that's just what it's called. It's perfectly reasonable. So, and drawing is a little bit funny on a graphical user interface like this. That whenever a window pops up over another, then it can kind of erase what's in that other window, and then paintComponent would get called again to redraw it. So what goes on in here can be drawn multiple times, every time that the window needs to be redrawn for whatever reason. So, but at any rate, we put drawing instructions in here: draw a line, draw a rectangle, draw an ellipse, draw some text, and out of that we get some pictures. So we have to draw on something that's kind of like system.out, except it's not system.out. It's called a graphics object. And again, for annoying reasons, the graphics object is not good enough, and at some point they improved it and turned it into what's called a graphics 2D. And did they change the argument type of paintComponent? No, sir, they did not. They left it the old way, so that we have to do some mumbo jumbo to get it the way we want. Just copy and paste the stuff. It's not worth worrying about. Now we're finally ready to do something. Now that we have a paintComponent, we have we have our graphics context. Now we can draw, say, a rectangle. We make a rectangle object. That's kind of reasonable. When you want to do something with rectangles, you make an object of that class, and then you call the draw method on the graphics thingy that's like system.out, and you say, draw this box. At this point, the box will actually appear on the screen. If you want to draw two boxes, like here, then here we take the box, then we translate it, that just moves it by a bit, and then we draw it again, and that way one of them shows up here, and one of them shows up there. I could have made two objects of type rectangle and drawn each one of them, but it seemed simpler to draw one of them and translate it instead of constructing it all over, because they had the same size. You could also grow on this thing and it would get bigger, whatever you want to do. So the code that we actually care about for drawing is I hate you too. Oh no, it's finally coming. So the code that we actually care about is this. And this is 1, 2, 3, 4 lines of code, with a bit of comment. And to get those 4 lines of code working, unfortunately we have about 20 lines of just boring code that puts up frames and components that we're not particularly interested in. And so you really want to copy and paste those. So let me demonstrate that. And make an application. What did you always want to have drawn?
Star.
All right. How about I do a cross? Just have to type it. All right, so I need a class, and I need 2 classes. I need the viewer class, and I need the component class. So let's copy and paste. Now this is a component. Do I have a viewer somewhere? Just going to get it from the book code. Rectangle viewer. Here it is. Okay, now of course I have to change every rectangle to whatever it is that I actually want to be drawing. In this case, a cross. I'm just going to take out the title. Who needs it? Now the component, I'm going to have to make a cross component, and here also. Alright, so that was my viewer. It won't compile yet because I'm not done with the component. So let me load the rectangle component in my text editor in the same way. And now put it over here. So I have to, again, rename this thing here. And now it should be good to go. Now I'm going to run it. Oh no, wrong thing. Main. Well, that doesn't look like a cross at all. What happened? Why doesn't it look like a cross? Yeah?
You imported the rectangle thing, but you didn't really change it.
That's very true. So I took the rectangle thing, I changed all the rectangle names to cross, but I didn't change the drawing instructions. So I have to change the instructions so that on this thing here I actually draw a cross. So let's say we want to just draw one thing like this and one thing like this. And so in order to do that, I have to figure out what are the coordinates of these endpoints. So the coordinates, the coordinate system goes like this. X-axis goes to the right, y-axis goes down. So I have to kind of estimate what this point might be. So give me some coordinates for this one here, for this point here. Yeah, it would be fancy to have it to have it depend on the frame size so that it would always be centered, for example. But we're just doing the quick and dirty thing. Give me your choice of coordinates for this point. It doesn't usually matter, but it does matter that I get an answer.
100, 100.
Excellent. 100, 100. That's exactly what I would have done. So, okay, I'm not trusting that thing there anymore. Okay, 100. No, that's crap too. 100. All right. And then what should this one be here?
200, 200.
Excellent. Okay, and in that case here, now what is this point over here?
100, 200.
Yeah, this one, we don't have a choice anymore. This one we actually have to figure out. So the x-coordinate is in this direction, is the same as the x-coordinate of the one over here, so it's 100. The y-coordinate is the same as this y-coordinate, so this one must be 100, 200. All right. So that gives us enough information to actually put in the drawing code. So in the cross component, I can now put that. So now, of course, no longer a rectangle, but it is a what? Is it a line? Didn't we have a homework assignment about this?
Sorry, could you repeat it? What did you say?
What's the name of the class that I need to make an object of?
Oh.
Exactly, it's a line2d.double. I know it's a weird name, and I'll just call it line1. So it's a new line2d.double of 100, 100 to 200, 200. And then that's what I'm going to draw. This one time I'm not doing the translate thing. I'm going to make another object in a minute. So I'll compile. Package line2d does not exist. Oh, what the? So what do?
You have to import.
I import Java awt.geom.line2d. Okay, compile. Okay, compiled. Let's run it. And here is one of them. Hey, this would actually have worked as a submission to the homework. So now let's do the other line. Let's do a bunch of copy and paste here. Line 2. And this one goes from 100, 200 to where?
I know. Asking for trouble.
So this was 100, 200.
Which point are you making?
Up here. I'll read through this line, and now this one.
200, 0.
Okay, he says 200, 0. Okay, well,
Or chicken scratch, chicken scratch.
Yes, okay. It is very annoying. Let's try it. So 200, 0. Close enough. So what was it actually? 200, 100, yeah. Okay, excellent. So so what we've succeeded is to make a simple drawing, and the important part is again that there's a few lines of code that actually contain the code of the drawing. These are these 4 lines. And we're making an object, we're drawing it, we're making another object, we're drawing it, and the rest of it is just kind of mumbo jumbo that one just has to do. So every time that you need to produce a drawing, and maybe some kindly soul already gave you the boilerplate code, like in an exam situation, I would just give it to you. And so there would be no sense to write it. And then you just need to home in on that spot where you put in the few lines of code that do what's necessary. Or in a homework, you just might have to laboriously do that renaming thing that you just saw. Now, you can produce just about any drawing in this way by putting in more and more complicated instructions here. I have seen people draw an entire Tyrannosaurus Rex out of nothing but line segments. Yeah, that's true dedication. And I'm not recommending to do that because you don't learn that much computer science by drawing several thousand line segments. But whatever. But now let's say that we want to draw something. Let's say that that poor fellow wanted to have 2 Tyrannosaurus Rex. One here and one here. Then at that point, yes, one could have 4,000 lines of code and draw them all. Or one can be a little bit smarter and make a third class that stands for a particular object, because then you can draw it multiple times. So in the book, the class that I do that with is a car. If you go into chapter 3, there is an object of class car that knows how to draw itself by drawing the body and the wheels and stuff. I'm going to go through the same process now with a simpler one. I'm going to make a class cross that just draws that thing at a particular position on the string. So when you do that, you make a new class. Now I'm going to leave these things inside because I'm going to need the basic structure. I want to have a method that I call draw. It's a good idea to always call them draw. And it takes a graphics 2D G2. Cross. Just out of force of habit, I'm putting in the Java doc. Let's get it out of the way. G2, at param, G2, the graphics object. And starting with homework 9, I'm going to make you do this stuff. So now I'm going to draw across. But of course, the way I want it is, since ultimately I want to be able to do multiple crosses, I have to find some way of drawing them at different locations. So when I construct the cross, I have to give the location by giving some x and a y value. And then I'm going to store these. And I guess I should also give a size. So that way I can make crosses of different sizes. All right. So let's compile it. Can't find graphics 2D. Where's graphics 2D? I wonder if it can. See, remember, you know how NetBeans, when you hit Control Space, it actually finds it for you? But BlueJ doesn't. No matching completions. Import Java AWT dot. I'm going to tell you something that is a closely held secret. I can import everything in Java AWT by using a star like this. Cannot find variable y. Why can't it find y? I haven't created it yet. I've taken the x that was given to me, but I still need to make those. Okay, now it'll compile. Of course, it won't draw anything yet. So now we need to figure out how to draw this thing, and that does require a certain amount of math. So I have my cross here. So let's say that size, to make my life simple, is this distance here. What's xy going to be? We have two choices. Is xy the center, or is it the upper left corner? And it's our choice to make. We are designing this class. What do you prefer? Yeah, choices suck.
Big?
No, my question is xy this place or this place?
It's make it the center.
So he wants to make it the center. Why?
It just seems as if we base every line off the center.
Okay.
It's all going to have a similar point.
Okay, so he says if one has the center, then one could draw 4 lines, I guess like this. Does anyone want to use the top left corner? Why do you want to use the top left corner?
Seems the most natural.
Ah, okay. So I want to use the top left corner too, but for a different reason. Namely, that's what rectangle does. When you make a rectangle, you give the top left corner. And so I figure that other programmers who are going to be using my class, they're already familiar with that concept. Now, actually, I always find it inconvenient that rectangle and circle use the top left corner. I wish they would use the center because that's how I think about them. But you have to fit into the world at large. So I'm just going to follow conventions, and everyone else gives the top left corner. I'm just going to do the same thing. So over here is x and y. In this particular instance, it turns out that that actually makes my code simpler, but that's not my reason. My reason is I want to make the public API, what other programmers use, as familiar as possible. All right, so this is x, y, and then what are the coordinates of the point down here? So what's the x coordinate?
X2.
How do I compute it? I mean, it's x plus size. Yes, so that was my question. How can I compute now the other points out of? So this is x plus size. And what's the y coordinate? Yeah, it's also y plus size because it's a square. I just call them both size. If it was a rectangular cross, then it would be x plus width, y plus height. But this is just also y plus size. All right. Let's code it up real quick. So over here, I now draw 2 lines. Um, from xy to x plus size, y plus size, and the other one, I'm just going to tell you, it goes from x plus size y to x y plus size. I know this because I did it before. All right, so now I have my cross class that does the drawing. Notice here I was too lazy to make the object and save it. I just make the object, pass it to draw right away. All right, now let's put it to use. So in my cross component, I'm going to draw a couple of crosses. Yes, I would like to edit it, please. So cross C1 equals new cross 100, 100 and size 20, say. C1 draw. C2 is new cross 300. So 200, 200, 100. C2 dot draw. Okay. Let's compile it. I made an error. I forgot to import that thing, and we run it. Now, all right. So here you see one of the cross objects, and here you see the other. 2 instances of the same class. They're both a cross, but they look a little bit different because I constructed them a little bit different. So that's what I wanted to show, that I wanted to give you another way of visualizing an object. This particular object, this particular class makes these shapes, can make as many of them as you like, at any position that you like them, and you just can visualize them with this program. All right, let's move on to the lab. Yeah, I trusted that now to turn this thing into a star is actually pretty easy. I'm going to have you make it in 2 stages. The homework that is due on Wednesday, you don't yet have to use your, you don't make your own classes yet. You just make a simple drawing like I did in the first episode, where I just made a single cross. And so to make a single star, you just keep on going and you just add a couple more lines. You know, everyone should be able to really do this. Watch the video if you can't do it by yourself. And then I'll have another homework. In homework 9, I'm going to ask you to do the classes, the separate class, so that you do that transformation with your own hands. All right, in the lab, I think this is a non-coding lab. So we're only doing part A today. This is 46B labs, never mind. Yes. So you and your buddy are going to get out a sheet of paper, and we're going to do exactly what you saw me and the fellow over there do. This one of you records what's happening to variables on the sheet of paper, and the other one reads the instructions. And it works best if the recorder does not actually see the code. Just shout it to each other, just like what you've seen going on the board before. All right, so walk through this, and that should be easy. You need paper. Is there anyone who has no paper and pencil on them? So I don't have to go to the office and ask you. Any people who